on. Okay, as you heard, the recording is in progress, so you might decide on your own whether you want to have your camera on. Welcome to the session on identifying and describing instruments in schema.org, organized by the Persistent Identification of Instrument Working Group. And here is a list of speakers. So I myself will give a short introduction. Then we have Steve, Lucas, and Renaud, who will give us some more insight on that. First of all, I'd like to welcome all new RDA members, and I'd like to remind you on the 6 guiding principles of RDA communities. So we are openness, consensus, inclusivity, harmonization, community-driven, and non-profit and technology neutral. And a few words on what is a persistent identification of instrument working group. So we set us our missions that we want to explore a community-driven solution for globally unique identification of measuring instruments in the science. And we were formally active as a RDA working group already some time ago, from March 2018 to October 2019. We did a few things. Among others, we formulated the PIT-IN schema for the metadata describing an instrument to be registered with a PID. So now we are formally still active in maintenance mode, but in fact, we are active. Right now, we are working on the next version of the PIT-IN schema, and you are all invited to join that discussion. But that is not the subject of today's session. What we are discussing in this session is on how to use the PIT-IN schema in schema.org. So the PIT-IN schema by itself is formulated in a technology agnostic way, just defining the properties that you should consider for describing your instrument. And there are many applications for scientific metadata that make use of schema.org. So naturally, the question arises on how would you describe your instruments in schema.org, or is there a way to map the PIT-IN schema to schema.org? And we kind of felt like we were called to give an answer to that. But in our group, we don't have any schema.org experts. So we invited a few people who can give us insight on that question. And particularly, the question would be how to represent an instrument description in schema.org based on this PIT-IN schema. But related to that is how to establish the link from a description of a data set in schema.org to the instrument that collected the data. And as I said, we invited 3 speakers to make a suggestion on how to solve that problem. We have Steve Richards. Here we have Lucas Lamparter, and we have Renaud Daum, who will all of them, I guess, make a suggestion on how to solve that problem. And as usual in schema.org, there is not one single solution to do that, and I assume the suggestions will be a little bit differently. And therefore, that gives us ample, enough topic to discuss that and to discuss what would be the best solution. And yeah, we will try to find a conclusion or decide whether we find a solution. And again, I have the link to the collaborative notes as a QR code. And with that, I can already stop my sharing. And I would ask Steve to start your presentation.
Good morning, and I will set up this, get back to the beginning here. I'm Steve Richard. I'm working with the Cross-Domain Interoperability Framework project, among other things. Also working on sample registration and other metadata schemes. But I'll be talking this morning about a proposal that we're working on with the Cross-Domain Interoperability Framework for describing instrumentation. And just a brief summary of what is CDIF, as we call it. It's basically a set of guidelines for exposing resources with fair cross-domain interoperable metadata. It's been a project that's under the auspices of CODATA. Simon Hodson is sort of our chairperson of this effort. We were involved with World Data Project over the last couple of years. And what we're doing is developing a set of profiles or conventions that are based on deployed standards for metadata to support various functions for fair data discovery, describing data structures, provenance, data access, how to automate the processes for accessing secure or personally identifiable information data, and then also how to describe packages of data, things like RO crates or baguettes. And the idea is to have a progressive tiered system for easier adoption. And mostly we want to use existing technology approaches for implementation. So we're not inventing new stuff. We're trying to make recommendations about how to use existing schemes in a way that streamlines interoperability. So as far as describing instruments, what's our use case? Well, this is fitting in the provenance metadata for data sets, and we want to be able to specify what equipment, instrumentation, or sensors, things like that were used to acquire or process the data that's described in a data set. And we're plugging into schema.org using a prov property. This is a probably debatable point, but we're using prov was generated by, and then typing the data type with schema action and prov activity. And the critical part for describing the instruments is, what kinds of things did this activity use? There's a bunch of other things in here, but we're interested in this prov used and schema instrument. And so what's the schema.org definition of what they mean by instrument? And it's the object that helped an agent perform an action. So that's pretty generic, but I think it's close enough for our purposes. And the values are expected to be of schema type thing, which means anything. So that's also very convenient for our purposes. So what are the properties we're interested in? And this comes from the PIDINST scheme. So we want to know about ownership. We want to know about manufacturer, the instrument model, an identifier for specific instrument instances when they were commissioned. So people change configuration and properties of instruments over time. So actually you want to timestamp an instrument description to know, when is this description applicable, because instruments change over time. We want to know what about instrument type. Instruments have parts. So if you're looking at a complicated liquid chromatography, multi-collector mass spectrometer system, there's a bunch of different parts there. So just saying it's that big thing altogether, it doesn't provide enough scheme. So we want to be able to describe the parts of the instrument, and then we have domain-specific properties. Right now, this is where we're plugging in the measured variables, if they're a variable, as an additional property, but also lots of other different parameters that are specific to different kinds of instruments. Developing a schema that's going to account for any kind of instrument seems out of scope and unlikely to get much traction. The idea here is that you can use the schema additional properties with defined terms from vocabularies for property IDs to be able to, within different communities, define vocabularies of properties you're interested in for specific kinds of instruments. And I've been working with a lot of astromaterials geochemical data, and we have about 60 different analytical techniques we're trying to account for, and this is the approach we've been taking there. And then the other thing in the schema that we're implementing. This is just, there are a few other things I'm leaving out, but anyway, we want to be able to just have relationships. So links to documents describing the instrument, instruction manuals, user guides, publications related to the instrument. So it's a way to have sort of a generic linked data connection with other things. And that's using a schema.org related link property. So without diving deeply into the details of what the implementation looks like, these are some of the main things I think that are useful to know about how the implementation is working. So we're typing using the type schema product and schema thing, and we use product here because a variety of these properties we're dealing with are specific, and schema.org expects for schema product, and to be able to run it through the schema.org validator, we are using multiple types here to keep the validator happy, just so it doesn't throw a lot of errors for things that really aren't errors in for what we need to do. So the manufacturer is described as an organization. The model uses a schema product model property. The instrument type uses schema category, and we're using defined terms so we can have instrument type vocabularies that have URIs, labels, and a vocabulary scheme identifier. The owner is a scheme organization. Like I said, we're using additional properties for instrument-specific properties, and the idea there would be this is using a property value structure, and that can have an identifier in there. I didn't put the identifier in here, but has a name for the property and the value. There could be a property ID, which would link to a controlled vocabulary for better semantic control. And then the idea of being able to describe the parts of an instrument. So using has part, and the parts are other instruments in general in this perspective. And this is just one simple example. So these are pulled from a full example. The way we're implementing this stuff is using the Open Geospatial Consortium building blocks, if you're familiar with that. But we have little component schemas for that. And if this link down here in this instrument folder where the examples are, there's also a JSON schema and shackle rules for this, and you can see the full schema. If we had time, I'd walk through the whole thing, but that probably would be overkill in terms of time available. But there's some other stuff in there too that would be interesting to talk about. So issues here. So first of all, this is a work in progress. It's just a draft. We're looking for feedback and we want to get agreement, on the approach to use here, so we're consistent with, in the community. And the other issues are, like I said, we try to make these things work with the schema.org validator. Right now, when you run the example through the validator, you get a bunch of warnings because we're using properties, values that aren't expected. Dog alert. And so there's a bunch of warnings, and generally I don't worry too much about the warnings. But there are places where we're using defined term in place of text, and this does throw an error in the validator. This could be avoided by using plain text, but then we lose the ability to have the semantic precision that defined term gives you. So at this point, we're saying, well, we can live with those errors because really in schema.org, it should allow you to substitute defined term for text, in my opinion. And if you look in the schema.org issue tracker, you'll see a bunch of discussion about that. So that's what we've been doing, describing instruments in the context of PROV used in our schema.org records. And I'll turn it back to you with that, Rolf, unless there's any questions, comments. Or do you want to hold off on that, Rolf?
I guess we will take questions after the three presentations.
Great. Alrighty.
Okay, thank you already for that. And then we will move over to the next speaker. That would be Lukas Lamparter, who will tell us a little bit about the Helmholtz knowledge graph and what he does with instruments there.
Thank you. Hi, I'm Lukas. I'm a software developer at Forschungszentrum Jülich, and I will talk about how we model instruments in the Helmholtz knowledge graph. there will be overlap, just as a disclaimer before, like to the presentation before, which is, I think, maybe also a good thing, because when multiple people have same ideas, that tells you that you're going in maybe the right direction, right? Okay, maybe a 30-second introduction what the Helmholtz Knowledge Graph is. So the Helmholtz Association consists of 18 independent research centers, and the keyword here is independent. Usually independency is a good thing, but here it also comes with some challenges. So 18 centers independent means we have everything 18 times, 18 libraries, 18 data repositories, data code repositories, and so on and so on. And all of these repositories using their own metadata formats. So the Helmholtz Knowledge Graph is the attempt to squeeze it all again together to one big graph using one unified metadata format, which in this case is, in our case, is schema.org, and that's also why this discussion is so important for us. So most of the instruments in our graph are actually coming from DataCite. And when you check DataCite, how they model their instruments, how they represent the metadata about the instruments, you can see that they're not only storing the metadata itself, but also the connections, right? And this is, as we heard before, like the interesting part. How is this instrument connected to this data set or to this article? And this is, of course, something we also want to have then in our knowledge graph. And the other actually great thing about DataCite, especially for us, is that you can request this data directly in schema.org. And yeah, let's see how that works out. So what you see here is like a table with 3 columns. The first column is the PIT-ins property. The second column is then the mapping to the DataCite properties. And the right column is the mapping as it is right now. When you request the metadata of an instrument from DataCite in JSON-LD, that's what you will get. And the funny thing here is, and I'm not quite sure about the reasons, that the DataCite mapping tool called Bolognese is actually mapping instrument to schema.org creative work. And that leads to some strange side effects. So, for example, the owner of an instrument is becoming the publisher, or the manufacturer is becoming the author. And that's not, like, let's say, an intuitive approach. If I imagine someone would use the knowledge graph to look for an instrument they could use in their experiment. So then we checked other schema.org classes to see if we could get a better fit here. And what we came up with is schema.org individual product. And the definition of an individual product is a single identifiable product instance. For example, a laptop with a particular serial number. And this was actually the reason why we went for individual product and not only product, because then we can, like, this serial number property then makes it able to distinguish like instruments from the same class, so to say. Like, this is the same as, like, you have a, I don't know, a VW Volkswagen, right? But this is another one than this one. And yeah, so, and actually this is coming pretty handy. So most of the properties you can really map one-to-one. Like, an owner stays an owner, a manufacturer stays a manufacturer. There are also properties that DataCite as right now does not have. For example, the model property for PIT-ins is not mapped, but with schema.org in an individual product, you could actually map it. And yeah, so I think we heard a little bit about this kind of mapping before, so I will skip this a little bit. But the bottom line is here, it's a pretty good mapping. It's not perfect, but it's pretty good. I would say it's something like an 80 to 90% solution, which is, from our perspective, what we face in our daily work, a pretty good mapping. Yeah. And but it's not only about the properties of the instrument, but also about the relation, right? This is what actually, for a graph like we are, is the interesting feature. Like, how does this connect? Which data set was produced by this instrument? And how DataCite does this, it has this property related identifiers, which is actually a list. And this list is then holding an identifier and something that defines the type of the relation. So an instrument has a relation type to a data set called collects, meaning this instrument has collected this data set. Or when you have an article describing an instrument, the relation type would be is described by. And as we have seen before, this Bolognese mapping tool can actually map the upper part, the properties of the instrument, in this case to creative work. It's not perfect, but at least it's there. But the lower part, the relation types, are not mapped at all. So if we request the metadata of an instrument from DataCite in JSON in the DataCite schema, you will have all these nice relations. But if we request the same thing in JSON LD schema.org, you will lose all those connections to data sets and articles, which is for us, of course, not good. So then we thought about how to model these relationships, and then the logical step to start for us was to use Provo, right? We were actually already using it, so it was, for us the logical thing to do. And I guess most of you will know it, right? But the bottom line is that an entity can be like you have an activity that can create an entity using another entity, right? And this is pretty generic, but you can describe almost everything with it. So you can then say that a data set was generated by this activity using another entity called instrument. And this is also coming in handy because there is already a mapping of Provo to schema.org, at least on this generic level. So you can more or less be replacing it one-to-one. So an entity becomes a thing, an activity becomes an action, and an agent becomes a person or organization, and the properties are named a little bit differently, but it's more or less one-to-one. And then you have a create action, which creates as a result a data set using an instrument, which in this case is of class individual product. And then you can take it all together, put it in the schema validator, and it turns out nicely. So this is like the metadata I showed you in the third slide from DataCite. So I mapped it by hand, put it in the schema validator, and it works out pretty nicely. So we have the create action on the top, which has a result, which is this data set. And it was using an instrument, which is here of type individual product. And this is then the properties of this instruments. And the article which was describing this instrument is linked down here with the property subject of. And so this is already just the overview about how we approach this problem. I mean, this is work in progress, so we are pretty curious about this meeting. So we are pretty open for discussion and for other approaches. But that's what we did so far. And from our perspective, schema.org individual product is a suitable candidate for mapping the properties of the instrument, and Provo would be a suitable candidate for mapping the relationships to other entities like data sets or articles. And what that of course would also require is then to map also the other relation types from PIT-ins. So I was just talking about is collected by and is described by. So the other relation types would also have to be mapped to Provo/schema.org. But this is where we are so far. And I'm looking forward to our discussion.
Thank you, Lucas. And we have a third contribution to that discussion round from Renaud Derm. Do I pronounce the name correctly, by the way?
Dwim.
Okay. Sorry for that.
No problem.
And so you were, discussing or adding to that discussion on how to map PIT into schema.org earlier, and that's why we asked you to share your thoughts about that.
So sorry, same as Lucas, but it's going to be an overlap of overlap. So not much new because I actually looked at what was done by what was done by Stephen, mainly the CDIF framework, and but I think we have a common approach on what we can do. So let me just share. Do you see my screen?
Yes, we do.
Okay. So the idea was to really to look at what we have on PDINST and see if we could have a mapping like the one we have for datasets. So exactly what you presented, actually, Lucas. So I did the exercise of looking at what was available on schema.org. So just stuff we didn't see before for people that are not aware of the model. So in schema.org, you have a lot of entities. Here, for example, you have the one that are really common: article, dataset, the defined term, what was Stephen talking before for keywords. And I came to the same conclusion about using the individual products. So the main difference is that a product is a generic product, and the individual products, here you have the official definition. So it's a single identifiable product. So all these definitions are available directly by this URL if you're not familiar with schema.org. So really nothing new on what I'm going to present after. So on the left, you have all the fields that are defined in PDINST with the mapping we can have in schema.org. So a part of them are coming from the thing type. So there is a inheritance in schema.org. So name, description. Once the basic usage you can do with schema.org is first included in a page. So exactly here you have a JSON LD snippet that you can include in your page, and with the JSON LD playground tool, you have the RDF representation of this data. So here, if you define the name, so it's related to the domain schema.org name. So you have all these predicates that are defined. So when you create a mapping, you can validate it either with the JSON LD playground, which is generic, or the schema.org validation tool that was mentioned by Stephen before. I think something that I think the ownership was mentioned as well. So there is a way to link the ownership. I'm gonna go fast on this one because it's really repeating what was done before. So here you have the definition and the types that exist in schema.org. So for the owner, manufacturer, it's the same. It's directly on the type product. It's not inherited from the thing object. The model, so as well, is directly available in the product type. You also have the brand object that can be used also. It's mentioned in PDINST, so you can use the brand object as well. So for the instrument type, this was mentioned by Stefan, and I think, Lucas, you have the same approach, I think, for the category. So either you can use for instrument type and measure the variable, you have the category or the keywords. So as mentioned, Stefan, I like the way you use defined term to have instead of having a basic keywords. So maybe I have a few questions for you, Stephen, after. But there are recommendations about how you can use these keywords on schema.org. Just as a note, I think there is a measurement technique property, and I think we can't use it as it is now. And I suppose that's why also you didn't choose it, Lucas, Stephen. So there are various dates. These are the one related, the only dates you have on product, but I think they're probably enough to start: release date, production date, purchase date. And And the related identifier, I saw, Lucas, you use the subject of in your example. So you have relation. And I have question for you as well, Lucas, on how you model these relations. And for the alternate identifier, so the serial number. So the serial number is only available in the individual product. But on product, you also have a product ID. It's a bit weird on the model. But they both inherit the property identifier. As well, there are recommendations about how you should use the identifier. There are many ways to use that in schema.org. But I've put a link to the using identifier as property value. I think in CDIF you use that as well, Stephen, if you can confirm. And that's it. So there are really common approaches. And I think for the probably the next steps will be to have a set of example. I've seen that on CDIF you've pushed example on your GitHub quite recently, Stephen, and they're quite good to start with. That's it.
Yeah, thank you, Renaud. So apparently we have much more, say, agreement than we expected. Are there questions, comments on the presentations?
Maybe I can start with one question for Stephen. You showed that you can use multiple inheritance, multiple types for object. Can you just explain what does it imply and how you use it for CDIF?
So,
For example, let's say, for example, you have you use product, but internally you have other types that you would like to use or other ontologies or
yeah, so you know, the JSON LD implementation lets you have multiple the type property, and so it can be a schema data set and a schema product. And I've sort of been pretty flexible about that. You know, if there are schema.org properties that are useful for describing a data set, let's say, but they're in the product, you know, the domain is defined, you know, because the way the RDF, the schema.org definitions are all expected values, right? Expected domain, expected whatever it is. They're not really constraints, they're just suggestions. And so you know, to me, it's like, well, if there's a property that, like defined term, I mean, it seems to me like it would be perfectly reasonable to be able to use defined term anywhere you have text, like a category. Why aren't categories defined terms? But in that case, it does throw an error. I'm not sure why the validator throws errors for some things and not for others. And sometimes it throws errors for things that aren't errors too. You've probably seen that. So yeah, so using the prov properties is more problematic, right? Because they're in a different namespace. But the validator ignores things it doesn't know about. So it still validates the schema.org elements that are inside your instance, but it doesn't really throw you know, when using prov was generated by hasn't seemed to cause any big problems for the validator. And because the descriptions we're doing are from the point of view of the data set, you know, it's nice to be able to say the data set was generated by some action, as opposed to having to define, you know, if you're building a graph, it makes perfect sense. You can define an action and have the result, and then use a reverse relationship to link the data set to the action. That gets a little bit convoluted if you're thinking about serializing JSON LD docs. One of the other things, you know, kind of constraint that we're operating under is also, you know, we recognize JSON LD is, you know, superior because the semantics are more precise. But in point of fact, there's still a lot of developers in the community that, you know, balk at RDF, right? And so being able to have a JSON representation or to say, this is just plain JSON and it works with JSON schema validation, and you don't have to worry about the RDF aspects, the graph aspects. We want to be able to do that. So that's one reason why we like to be able to have the hierarchical structure. So we do, we're working on basically being able to transform between the JSON LD flattened view and a compacted, more framed view that works with the validator. I mean, with the JSON schema validation, trying to, because especially like if you want to look, use the scheme in an RO crate, you have to, the RO crate expects its metadata record to be in flattened format, which has been an interesting problem, and RO crate's a handy way to be able to bundle data, and a lot of people are using it, I think. So we want to be compatible with that. I don't know if that answered your question or not.
Yeah, that's clear. I have just another question. Initially in what I've seen on the web is that there was a group working on schema.org called Science on Schema. So acronym SOSO. Can you explain how you work with them, or are you part of this initiative, and how you link your work with what they do? Because I think that what they provide could be a really good base, so we all align on what is available.
And so, yeah, so actually I was involved with the development of the Science on Schema.org as well. It's under the Earth Science Information Partners, if you're familiar with them, ESIP, as an organization here, I guess largely in the US, but we do with outreach in various places. And that Science on Schema.org grew out of a NSF project called EarthCube, if you may have heard of, some years ago now. And so I was involved with the group that developed that and contributed that. Right now, it doesn't include much prov stuff, but the C. diff discovery right now is aligned. I mean, it pretty much is schema.org, Science on Schema.org. There's a couple of subtle differences, and we've been in discussions about how to iron those out. So I know those, we're working together and really trying to keep those things aligned. Is anyone else? I don't see any of the other SOSO perps here anyway. So yeah, we definitely want to stay aligned with that activity.
Yeah, that's great. If we could align, I think, on the way we link dataset to instrument with the prov and also with datasite, as Lucas presented, it would be great. So there's no question anymore on how we should do that all together.
Right.
Even if it's not perfect, at least it could push to have this line at some stage on schema.org, and yeah.
So in terms of promoting some discussion here, and Rolf, I guess we have is there a GitHub not GitHub, well, I guess there's no GitHub, but maybe a Google Drive location where we could post some example instances to compare, and it'd be nice if there was a way to sort of be able to comment these things and to have some discussion, looking at particular things. Like, for instance, with, the question of identifiers. So in the way we're doing it, we put everything in the schema.org identifier. And so within that, we're using property value, because with property value, you can say what the scheme is for the identifier, and you can say this is a serial number, or so it's an instance number, whereas this is a model number, or this is a DOI. Sometimes instruments have DOIs now, like you were showing us. And I think the philosophy in the C. diff group is always to try to minimize the number of options for how you represent the same information. So essentially, I mean, serial number is really another identifier, right? So if you have the option of having the identifier in schema identifier or schema serial number, then that means when you're writing code to parse this thing, you have to say, oh, did they put the identifier here or there, right? It makes things more complicated. So if we can reduce the number of options, and looking at individual product, I see logically that makes great sense, right? I mean, because what we're talking about is an individual instrument, right? But in the scheme, right, the only thing it adds is a serial number, right? And so, I think
that's why you choose product, to make it simple and to be at the top level of the hierarchy. Yeah.
That was the idea, yeah.
Yeah, so yeah, we could, yeah, understood. Yeah. So yeah, if we write that, why we choose product instead of individual products, because of the identifier, I think that's great, we can align.
For
I mean,
us, sorry.
sorry.
Okay. Yeah, for us, it was just the definition of product. That it starts with a product is any offered product or service. You know, it sounds pretty generic. So if someone would read up on the definition, right, that we felt more at home, so to say, with individual product based on the definition. It was not so much about the serial number, right? Because we usually don't find that anyway. So for us in the graph, it's not useful. Not that much, at least. It was more about the definition of the product, but we are super flexible here. So with product, we would be fine.
Okay, Ari.
Just kind of to break the discussion from only the panelists, but actually related to this one, at least to me, the individual product sounds much more kind of, at least for the use cases which are related to both data usage in some senses, but also for the organizational data kind of use cases for me. So for me, it's kind of I'm trying to find out what are the organizational requirements to implement this kind of thing in a really like in a university or a situation like that in Netherlands. And for that one, it is important that there is also like the serial number that was just mentioned. I think this is organizationally really important because this is the thing which can be then connected to the inventory what the organization has. They don't have a PID, and they will not understand what the PID is in the administration. They will understand that this is the serial number of this machine. That's one use case for the kind of having identifier for the instrument, but then also the fact that individual instruments can differ in time. And there's a lot of scientific use cases where exactly the same instrument, both from the same company, through maintenance or whatever individual changes, they diverge. And then if you want to really come back to how this actual data was measured, I think this individual instrument, at least to me, sounds like a very good match, or individual product sounds like a very good match for this. But the real issue for me also in my head is how do we make sure that kind of the same kind of instruments are also mapped to the same. I'm already thinking all the problematics of making sure that they are identified identically, and I don't know, but this was more of a comment for this discussion, but I do see the more both of the viewpoint.
Yeah, I would maybe get a little bit in the same direction. So my question would rather say, if I look at such a schema.org record, how do I recognize what I'm talking about? How do I know that this is supposed to be a scientific instrument? I mean, if the type that I attach to are, say, too generic, then I might be kind of lost on what we are discussing here. I mean, maybe Steve or Lucas, do you want to reply directly to that?
I would throw in one of the things I left out in the sketch there is we're actually putting in additional type, using the schema additional type, and putting in the Wikidata identifier for instrument, which actually is a better definition of what we're talking about. There's a Wikidata URI for instruments, so we're actually putting that in as an additional type. We didn't want to put it in the @ type because that would then start implying properties and connections that we don't necessarily want to imply, but it's semantic, provides much better semantic clarity on what we're actually talking about, I think, which is what you're asking.
Yeah, pretty much the same here. We're also discussing additional type here, and either using Wikidata entities, Wikidata nodes to identify that because it's super common, right? And everyone can understand it because from Wikidata type, you can directly go to the Wikipedia article, right? It's a very natural way of thinking, and understanding for the user, which is not that much familiar with the whole thing of JSON LD and linked data and so on. And there's also the GBV, I guess, has introduced a namespace for DataCite. You can actually have something that links back to the DataCite instrument type. I will quickly get the URL and put it in the notes because I don't have it at hand. But we also were thinking about adding that to additional type.
I believe you had it on your slide, so it's
Yeah, that's why I'm trying to find it back.
Jens.
I briefly want to come back to the serial number. I think that's, even though it's intuitively very useful, I think in practice it's not that useful because in our implementation of PIT-ins in the instrument register for ORSCOPE, we found that firstly, for the organization to know that number, it needs to be in value above the asset threshold. So with the big machines, that easily happens, but we also have smaller machines that don't cross that asset threshold. So there is no central register for everything, even within one organization. I very much like Ari's point about the divergence of that between the record and the instrument over time, and that's something that we have to deal with in our use cases with the geophysical instrument arrays that we model as evolving instruments. But something that I hadn't realized that the geochemists pointed out to me was that serial numbers of instruments are sometimes used as access keys to maintenance software, and they don't want to expose those numbers on the internet. So I think in many cases, the serial number is a straightforward identifier to use, but it has its difficulties.
Ari.
Yeah, just kind of coming. I'm not been the member of this group for long, but I think that was a really good point what Jens brought up about the publicity of some of this information, because this was discussed at Drop Node. There was this workshop on Netherlands on thinking of these instrument databases, and there was the discussion about having a national thing. But I would see exactly the problem, that there is a lot of information which you don't want to share in your schema. You might want to have an internal version of it and then the public version of the data. And that's also a thing which I don't know if it's really relevant for this discussion, but good to know that not everything in the schema you might want to expose to everybody, and maybe just keep it internally if you want to use the same thing too. And I think it would be good to use the same sheet to explain the one entity.
Maybe just a remark to that. So it's not related to schema.org at all, but maybe to the schema in general. I mean, the schema properties are meant for what you would register with a PIT or what you would put into public. These identifiers in general would resolve to some landing page, which in most cases would be automatically generated out of your own instrument database. And of course, you can put lots more information in that instrument database, and then you can, for each item, individually decide whether you expose that to the outside world or whether you make that only visible internally. And of course, serial numbers and these things are, say, for very good reasons, optional properties. You could put it in the PIT-ins record if you want to expose that, and if you don't, then just leave it out. So there's no problem with that. But others say discussions, opinions.
So I'm curious about using this, trying to describe the parts of one of these more complicated instrument assemblies. I don't know if anyone has had any experience with that. Is that really a useful thing to be thinking about here? Trying to describe a liquid chromatography mass spectrometer system, in terms of the components that are in it, or
I can definitely say that, at least from my experience, this use case is relatively common. It depends really on, of course, field of science, but where I was working in atmospheric sciences, it was common to have several instruments in a row, and it still is that you have basically something which does, for example, for air sample, it does certain things in a row. So you have the combination, which is called one thing, and everybody knows that it is actually components this, and this, but when you read then in the method section, it says that it was specifically these components of each one of them. And I could say that this is, at least if you want to get really like an interoperability on the level that you want to kind of fully understand what has happened just from the identifier, which is another question, is this necessary? You would need to have a way of identifying the individual components as well, and kind of the child parent relationships.
Just go ahead, Renaud.
Yeah, I don't know if there was at some stage a defined ontology for PDINST. So we have a domain, an official domain where we have this instrument type. For example, Lucas was suggesting using. I mean, would that make sense? So that we create an ontology where this term instrument is defined, so it could be used, for example, as an additional type in schema.org.
Definitely, yeah.
Yeah, I think there were some attempts in the past doing that, but if we could have a base ontology where we could express this mapping, it shouldn't be so complex to do, I think. So we know that we all align with the terminology with the PDINST terminology semantically.
I mean, for the PDINST group, I can definitely. So what we definitely probably want to do is to have some sort of recommendation. So trying to align our ways to express things in schema.org. Turning PDINST into an ontology is certainly yet another thing. Not sure whether we take that on or not, but I wouldn't exclude that either. But there should in any case be a follow-up activity on that session to say collect the results, and since we seem to be agree on most of the things, it would be a shame not to write it down and publish it somewhere. Lucas.
Yeah, just one more comment on the instrument that is part of another instrument. And so I think there's a lot of value in describing that. I mean, we from the knowledge graph, we're doing the stuff quite superficial, right? Because we're starting from a quite superficial level, and we are already happy if we can connect a data set to an instrument in general, right? So because that's already more knowledge than it was there before, but it does not mean that it's the useful knowledge. When I think from the scientist perspective, and I want to reproduce a data set, right? Then I need all the information, and so I see a lot of value this like has part of. I see also problems there, but let's start with the with the pros here. And I think here, what comes here really in handy is the difference between product and individual product. Because when you get very small components, you don't have the serial number anymore, but this is usually the place where it also doesn't matter. right? Because it's not that important if this, I don't know, this lamp is an LED or something else, right? You can just say the class of, I don't know, light source, something like that, right? The product light source, and that's already enough, and you don't have to have the serial number of this thing. And then you can maybe describe complex instruments without knowing too much about them.
Yeah, I mean, on these describing subparts and or describing everything, say, as complete as possible. Of course, it should be possible to do that, and there are definitely use cases for that. I mean, we do have, say, our MX141 experimental station. If I want to make a statement like this experimental station is equipped with a dexterous detector, then of course I need to identify the detector as well next to the experimental station. I just want to make a little bit a caveat of, I mean, it's not, say, for granted that everybody wants to do that because it's lots of work. And say I got a warning from our user office already, say they're happy to mint or to allow me to mint instrument DOIs, but who should maintain that in the end? And that is, for the moment, for us, the reason not to go into all the details, because it would create a lot of maintenance work. But we should have schemas and tools that are flexible, that everybody can describe it as much as they are able to do. And then some will go much deeper into the details, and some will just remain more on the surface. Ari.
Yeah, actually, this is a very good point to me, at least, because I do think that everything what we describe has to have a potential use case for somebody. And of course, I can see that in some cases, exactly the instrument might be a combination of several things from them. Maybe the data point is interesting, but sometimes it might also be that they have different funders, these different instruments, and later on you have to tell how much this instrument was used. And if you just use the combination thing, it might not necessarily, well, it should map to each individual component, so you can tell, okay, that was used as well in that use case. But I one question though, which comes to my mind now, is also that this might change in time. That you would have one PID describing one instrument, and then later on you switch one of the components because that instrument broke down, or you bought a newer, fancier version of it. How does this map in the current mechanisms, how these things work? Do you need a new PID, or do you have a way of presenting that this is now the new version of this? I'm just not familiar with this. This is a general question.
That's a really hard problem, right? and you know, one possibility might be to think about having as Rolf was talking about, sort of, or going back to this question of, you know, individual instrument versus, or individual product versus product, is have a sort of generic description of, say, you know, it's this kind of mass spectrometer or something. But then in the metadata for an instance for a data set, you have some configuration information or something that lets you be able to override that with, say, for this particular data set, these things were different from what the generic description says. Jens.
It's a bit of the ship of Theseus paradox, isn't it? Where you can model it as endurant or perdurant, and so the way we went with the geophysical sensor networks was to treat them as endurant and just reassemble them every time new. But with the mass spectrometers, to then describe them as much as perdurant as possible, because the shrimp at Curtin University will be the shrimp at Curtin University until it gets replaced, even though components change, but those changes are then all recorded in the versioning.
And you would put identifier, have PIDs on each version?
Yes. So there would be a kind of umbrella entity over all those changes, but then each time step would be identifiable.
Yeah. So the having a time, I think having a timestamp, is on these instrument descriptions is probably important. So this is what it was like at this point in time for this data set.
We were also wondering with some of the networks whether we would rather delegate that to RAID to say this was an experiment that was conducted. But there's also just the pragmatic decision of who knows about this and who makes the changes to the record.
Right.
Yeah, I mean, the timestamping is indeed an important issue there. So putting aside for the moment the question of who wants to put all the information together and who wants to maintain it, and assuming that we put in infinite effort into making everything perfect. What you could do if you replace subparts of it. I mean, if you identify the whole instrument and the individual part of it, both having their own identifier, and if you maintain these lifetime date stamps on the identifier level, then you can easily say, okay, that instrument had during that particular time period this component, and after that time period it had another component. Just by saying, okay, that component A was part of that instrument and it had a lifetime from, I don't know, 2020 to 2031. And then you had another component that has a lifetime from later on, and is also a part of that instrument. So from that you could deduce all the combination of the whole thing at each point in time, in a way. Ari.
Yeah, it's okay. They also comment about the dataset versioning as well. There was this very similar discussion what we had with the dataset versioning as well. Is that how you should cite a dataset which is in principle the same but has dynamically changed in the time by some amount, and what is the versioning aspect? And I know, Jens, you have seen a lot of effort on this one, so I see this as a very, very similar concept. Just a question about the PID in general, or the schema in general. Do you have a way of presenting that this is a newer version of certain previous PID? You do. Okay, then you could just build every time a new PID and say that this is just a new version.
Yeah, we pretty much took dataset as a model and adopted several things from dataset, and you can do that with related identifier, and then you have different ways of pointing to the other identifier. You can say is new version of that instrument, or in the other instrument is a previous version of this one, and you have the has part and is part of, or in PID-INS we named it is component of and has component. But yeah, you can do all these linking through related identifiers and the appropriate relation type that you attach to that link. Any more suggestions, input? I mean, otherwise, say coming back to that detail discussion between product and individual product. As I said, I'm not a schema.org expert, but I assume in individual product serial number is an optional property. So you may leave it out, and then it wouldn't say hurt you to switch to individual product in all times. And then I would say express my preference for individual product because it better matches our concept of what we want to describe. Jens.
I want to back Wolf's point about making that distinction, because we had all these discussions with RRID about where they are applicable and where PID-ins should be used, and this distinction would make it really clear.
So what would the distinction be then? Which one would RRID apply on?
RRID would only identify classes of instruments, not individual instances. And so in the discussion over the past few years between the two groups, we came to that distinction that PID-ins should identify individual instances, while RRID would identify classes of instruments, for instance. Or they also identify all sorts of other things like mice breeding lines and cell culture lines, but always on that kind of one-step abstracted level of classes, not of individual batches or individual objects.
It sounds like a good rationale for us to recommend using individual product. I mean, that works. I think I could live with that, no problem.
Steve, you asked about a place to put things together. I mean, obviously, the easy thing, just setting up a Google Drive, is of course a no-brainer, and we do have our space within the PID-ins group, and we could create a subdirectory schema.org in there to collect everything there. Otherwise, if we go to if things becomes a little bit more stable, then I would rather recommend to move things to GitHub where it's then versioned. So we might want to create a document, a recommendation document or something like that, and could maintain that under the auspices of the PID-ins group in our GitHub organization. Okay. Seems we are way too much agreeing to each other, so that we don't discuss anymore.
Can I, if we are kind of, I mean, of course, this was mostly about talking the schema.org approach, which is excellent discussion, but are we open for other things to discuss also in here, or what's the agenda? I haven't.
Well, we are pretty much through what we need to discuss for schema.org probably, and we still have 20 minutes of time. I would just in a sense, in order to wrap up this. So I believe we all agree that we should align, the schema.org approaches, and it would be very valuable to have some sort of standardization here. And I take that as an action for the PID-ins group to organize something like that. So I would assume that we will, if you all say contribute to that, then we might produce some recommendation document on how you should use schema.org for instruments and how you should link datasets and all that. So that is certainly something. Well, we will not do that ourselves. We will organize a process and hope for all your contributions. And we will probably discuss the details then in the next monthly meeting, which would be in like 2 weeks of time on the 1st of April, if I'm not mistaken. And yeah, okay, that's probably it. And then Ari, just continue with your other topic.
No, this isn't really another topic. I'm just kind of curious about, as Rolf knows very well, we are in Netherlands thinking about trying to work on this instrument identification in a more wider sense. And I'm working in 2 large Dutch universities. And one aspect of this one has been really to think about not only the technical aspect, that we have mostly discussed here, but really the pragmatic implementation of this kind of system in a wider context, like in a university-wide or faculty-wide level with a lot of different research groups and so on. So I was kind of interested to know if there's anybody with these kind of experiences, and have they been somehow collected when you did this kind of initial testing of the PID-INST, not only the technical aspect, but also like the organizational requirement, because I think this is very much, I at least am going to need this information, or it will come through experience then, because I need to convince quite a lot of different people, also in research group level, what is the benefits and things needed from them. So just kind of interest if there's anybody in the group who has this kind of experience and can share it.
I guess Schumann might want to comment on that, because you over there in Australia, you took a pretty much more, say, coordinated approach than anybody else.
Yeah, I can talk a little. We're very lucky to have had a strong national PID strategy, which has been organised through the ARDC, because we're part of the NCREFS facility, so National Collaborative Research Infrastructure something. It's a long acronym. So we've been able to put out some best practices around these things, drawing on what's happened here in this group, and also with the community, the larger research community within Australasia. We're actually just about to put out the second version of the recommendations for instruments, and the first one for facilities as well. Sorry, my cat just woke up. Sorry, I've lost the thread of what I was saying. What are you asking, Ari?
No, it sounds exactly like, I would be at least very much interested to know about these things, and whatever you have, it's would be really valuable, and to really kind of get the experiences, what worked and what doesn't work, if you have that, and I'm sure that we will collect similar things also in here, but just so that it's not kind of kept in the brains of people who are doing it, just to get a little bit of learning from your experience.
Oh, really happy to share process, and also I can share with you some of the templates we use for collection use cases as well. Drop me a line. Sure. Very happy to chat more about that.
I will do so.
Excellent.
Okay. More comments, more discussions?
If we have some time, I mean, maybe we can go more detail on this. Have you had real kind of challenges of convincing people to provide this kind of registration? What kind of argument have you used, for example? Or are other lab managers very happy to provide you all the necessary data? I think Rolf was mentioning also about the kind of sideways about that one, that how much detail can you ask from people and then they get annoyed, and what is the kind of the strategy you can use? I'm looking more for a soft solution rather than a hard one.
Yeah, maybe on this one, Ari, often when you did reports about your activity, then it's useful to have a unique ID for your instruments.
Yeah.
So, and for example, to know when there is a new instrument or an old instrument, often it's when you change people, you change the responsibility of the people on the instrument itself. So they want to have statistics about what they did on this instrument, even if there's no big variation of the instruments. I mean, at least on synchrotrons, that's what I mean. Every 5 years, we change the head on instruments. So we know there's a new instrument coming. So that's the way to. But as said, Rolf, it's really hard to know when you have a new instrument, because you never know. It's always configuration. So, but I think the first step with the schema.org is quite simple. You don't even need a PID. If you have a landing page of an instrument, every instrument has that. You can start with this, and the PID is probably the last step you will get to. But at least get the name, the abbreviation, stuff you want to. If you want to cite it better, then you can use PIDs. But for me, it's the last step. At least getting all the information, ownership, etc. It can be useful on landing page, even internally, if you don't want to have that public.
Lucas.
Yeah, maybe this is way beyond the scope of this discussion, but since Ari just asked, like, how can people be convinced to share the information, right? And I think you can, like, talking about researchers and coming from research myself, I think you can only get someone to share this information if you have also some upsides from that, right? If you have some, right? So if it makes your life easier, then you will do it. If it make your life not easier, you will not do it. And I mean, it's nothing like which we are scratching on the surface here, right? So it's not that direct. It does not have direct implication to what we do right now. But maybe in half a year or a year, like whatever we build on top of this very superficial description, when we get, then I think we have to really think about that, because researcher will not put the time in if they cannot get anything out for them. And this is going in the direction of, that they have automatically written that down in their digital lab book, because the machine already knows which filter setting it has or something like that, and then they have less documentation time to put in. And this is, I think, this barrier where it becomes useful to scientists, and where they will happily participate in it. And this, I think, more arguably one of the most important things to think about, because it's one thing to have like a beautiful description, but it's not worth anything if nobody puts in any data. And this is more like what I witnessed like 2 to 3 times in my university, right? There was always a new system and it always failed just because the people were not participating. So I think it's super important. And as a follow-up, we should keep that in mind, yeah. And maybe last thing. So I'm a biologist by training, and we have this OME, this open microscopy environment. It's developed, doesn't matter. But the point I want to make here is that I don't know how they did it, but the microscope itself, they have this metadata format which can actually import from all vendor formats all the information. And what then happens is that the machine stores the metadata already when producing the file. And this is the level of convenience. Like, we never noticed that we produced this data, right? We were not even aware of it until later it turns out and this is the level of convenience you need. So maybe this is also a good role model to look at how to, when we think about how to develop solutions like that.
I would add to that. I mean, you would also should also say consider the individual situation that you are placed in your environment, and the different roles that people have there. So it's depending on how you are equipped with or what your organization structure is, but maybe it's not all needed to be done by the scientists, but also by infrastructure stuff. And that is an important distinction that you maybe should assume that certain tasks are fulfilled by the organization and not needed to be done by the individual scientists.
I'll just add to that as well. As ARDC is an infrastructure provider, there's two things really going on. There's what the research community is already doing, and there's what we can set up for everyone else to use as, I call it research plumbing. So if we can work with research communities to develop slightly more heavy duty infrastructure that everyone can use, we take a weight away from from them having to do manual work or having to figure out configurations. We just do it at a national level. I know that's not possible for everyone. We're in a very lucky situation here, but where you can advocate for national or state-based, depending on the size of your country, I think that can be a very valuable part of the conversation.
I think this is a very, very useful discussion, because this is exactly how I plan to kind of approach this one also in the Dutch approach, is really to see what is the value kind of proposition for different use kind of communities. Also, what was interesting also in Netherlands, at least, and I think that's also behind the Australian system, was also that the science funder was very keen on this one, because they want to know where the instrument has been used, and people don't apply for similar instruments which already exist in the landscape. So I think that then there is, of course, I can see also the university bureaucracy is its own. They have their own use cases, but they might not realize the need yet for this kind of thing. And the laboratory managers were also discussed already. So I think they are also a key part of this one. But I'm just we are hoping in Netherlands, at least I am hoping that we will write something out which would actually approach these different stakeholders in a way that we can kind of give them a good value proposition for this. And that's kind of my why I'm here.
So I posted once again the link to the collaborative notes to the chat. So all of you, that if you want to be involved in the loop, then at least you should subscribe your attendance in that list, so that there is at least a chance to connect you. And then, as I said, the PIT-INS working group still has monthly meetings. The next one will be the 1st of April in 4 p.m. Central European time, which means 3 p.m. UTC, I believe, which is unfortunately probably not so friendly to Australian, but it's at least friendly to US colleagues to join. And we will certainly put, say a debriefing of that session here onto the agenda of that monthly meeting and discuss how we will proceed in practice with the results. Okay. Any more final remarks? Yeah, still have the chance to close the session 4 minutes early. Yeah, okay. If there's nothing more to add to that, then we indeed do that. And it was a very useful discussion, and I'm very pleased about how much it streamlines towards a result and to a common understanding of how to do things. And we definitely should follow that road anymore. One additional remark just comes into mind. We are right at the moment working on the next version of the Pit-in schema. And that was not subject of today's session. But if you want to be involved into that, you can look into the issues of the schema for the Pit-ins group. So you can check out the group page at RDA, and you will find a note on that about the work on the schema in that page, and you can check out the issues that are discussing the new properties. I can say it is not a huge change. It is just minor, things to improve. But we hope to have, a draft new version, I don't know, by something like by autumn. And we will then also, publish a result then. Okay. Having said that, and if nobody else, raises their voice now, then I will indeed close the session. And thank you all for your attendance.
Thanks for organizing this. It's been a really great
Thanks,
discussion.
Rolf.
And
Yeah.
all right.
Thank
Yeah,
you.
thank you.
Bye.
Bye-bye.